Good day, everyone, and welcome to Physics and Mathematics Lovers. In today's tutorial, we are going to be looking at trigonometric identities. We want to use this question to illustrate what trigonometric identities are talking about. You must know, in our trigonometry, we know that when you bring out your right angle triangle, we have three basic ratios. Then if I decide to put theta here, and this is your B, your A, C, okay, and this is your hypotenuse, this is known as the hypotenuse, and this is the opposite. So if I call here small c, I call here small a, call here small b. Okay, so if I say sine theta, it's going to give me what? Opposite over hypotenuse, which is c over what? B. I am not going into this, so you watch that for my next video, where I am going to be giving you introduction to basic trigonometry. But I want us to look into this question. We want to prove that what we have on the left hand side is equal to what we have on the right hand side. But before we can be able to prove this, we need to remember some of the trigonometric identities. Recall, if I have 1 all over sine theta, that is a reciprocal of the ratio. Remember, we have three basic ratios: the sine, the cosine, and then the tangent. So 1 over sine theta will give me what? Cosec theta. Okay. Now, if I have 1 over cos theta, it will give me what? Sec theta. Right? Then 1 over tan theta is equal to what? Cot theta. Alright. Now remember that even tan theta its own has its own what? Identity. Tan theta is equal to sine theta over cos theta. So this will be proved in our next video, where we are going to be doing introduction to basic trigonometric ratios. Now we have that what? Tan theta is equal to what? Sine theta over what? Cos theta. So that means that what? If I have my cot theta here, it's sitting as saying 1 all over what? Tan theta. Meaning that what? My cot theta will be equal to 1 over what? Sine theta over what? Cos theta. So when you take a reciprocal of a fraction, the denominator will have to come up to become what? The numerator. The numerator will go down. So it means that what? My cot theta now is equal to what? Cos theta over what? Sine theta. So this will be very useful in this our what? Proving. Okay. So having known all these identities, so we have to make sure that when we work towards achieving the left side, we are going to leave this. Let us work with this. We'll work with this. If at the end of the day we simplify this, and then we have what we have on the left here, it means that well, this statement or this equation is what? True. So now the right hand side, let's prove the right hand side. The right hand side, which is equal to what? Cosec theta minus what? Cot theta minus cos theta all squared. So your cosec theta is what? 1 over sine theta. Then while your cot theta is what? Cos theta over sine theta. Now, because of the squared, then we square all. Okay. Now let us first of all evaluate what's inside the bracket before we can carry out the square. Now the LCM now will be what? Sine theta. We have sine theta here, sine theta here. So that is the LCM. So if that is true, we say what? Sine theta is the what? LCM. If this goes here, it will be 1. Then 1 minus. If this goes here, it will be what? 1. Also multiply this by 1 minus cos theta. Then everything now all squared. Okay. Now let us open the brackets. If you open the brackets with that, we are going to have 1 minus cos theta all squared. Okay, because we are distributing this square to both the numerator and the denominator, all over sine square what? Theta. Alright. Now, there is an identity, trigonometric identity, that says sine square theta plus cos square theta equal to what? 1. So we are going to prove this in our next video, where I'm going to teach you basic identities and basic trigonometric ratio. Now look at it now. So it means that here we are going to have a sine. Let's make sine square theta subject of the formula. I'm going to have a sine square theta now will be equal to, take this one to the right side, to this, the other side of the equation, become 1 minus what? Cos square what? Theta. Okay, so we have 1 minus cos square theta. That is for sine square theta. Now, here we are going to what? Expand now. Let us expand. So in this case, this place now will now become 1 minus. Remember, this is a square. Become 1 minus cos theta. Then 1 minus what? Cos theta. That's what this square has to do with this. Then all over, since square theta is equal to 1 minus cos square theta, let's use it to replace it. 1 minus cos square theta. Okay. Now in this place now we're having something like what is called difference of two square. So let us simplify this further. Breaking it further, this will now imply that 1 minus cos theta equals 1 minus cos theta all over difference of two square. You have to remember that in algebra, if I have x square minus 1 or 1 minus x square, you see the same thing as saying minus what? 1 square. So it means that I'm going to have x minus 1, then x minus what? X plus 1. So if it is turned on the other way around, by having 1 minus x square, so it's going to be turned the other way around to become 1 minus x, then 1 plus x. Since addition is commutative. Now, we are going to apply that to this now. So mean that what here we are going to have 1 minus cos theta, then 1 plus cos theta. Alright, so at this point now we have 1 minus cos theta here, and this one takes care of that. Alright, so the next thing we are going to have now is what? 1 minus cos theta all over 1 plus cos theta. So which is equal to our left hand side. As you can see that what the equation has been proven. So we have proved that this one is equal to this. So when you also decide to use this one and carry out some other trigonometric manipulation, you are still going to have something like this. So this is our answer. Very interesting. If you find this class very interesting, please do not hesitate to share this video. And also do well to subscribe to our YouTube channel so that you can be getting more varieties of videos. So, bye.